last week's verification, the forecasts we made on Tuesday the 9th, and then we'll be hearing from Dr. Trabachino. So we'll start off, we got a bit of a tight schedule today, so we're going to start off, do 10, 15 minutes of attribution, 10, 15 minutes on everyone's forecasts, and then we'll let Lynne take the floor. So to start us off with some attribution, the most recent verification was for the window of June 3rd to June 7th. We made that forecast on the 19th of May. And again, this I believe was our third CDD forecast of 2020. So here we can see the archive page. Pretty strong performance across the board. Most people came in with positive CRPS scores above the 30-year normal of 30.8. Verification, however, was quite warm at 8 CDDs. We can see a lot of our human forecasters were sitting up top. Matt Lanza was our best performer, followed by Mike Garoon, and then Matt Rod. The 10-year had another strong performance, and that's something that we'll certainly be keeping our eye on, as a lot of people are starting to weigh that in their formulas. Maxar had a strong forecast. Dr. Roundy, myself, Dave, Philip, pretty strong across the board. We can pull up Maxar's page. Although the numbers aren't working today, we can see this was the average temperature departures for the US for June 3rd to June 7th. We can see, for the most part, very, very warm pattern across the US, especially in the central part of the country, including Kansas, Nebraska, and parts of Iowa. We can pull up the 500 millibar pattern from a departure standpoint. I think it's pretty clear to see what the pattern would be, though. Strong ridge pattern across, anomalous ridge pattern across much of the US, leading to those warm temperatures that we saw. We can report from that day. Again, they had a strong forecast, and it's clear to see that they have, from a pattern perspective, did a pretty decent job of getting that on point. And then we can come down, we can see the EC did pretty well, especially with the considerable warmth in the west. CFS, not so much, a little bit in parts of southwestern Arizona. I think if we come back here, there's the EC. Actually, the EC did not do so hot. So it looks like they might have, the EC got the west right, but because it didn't get the east right and parts of the central US right, that it struggled as well. We could pull up the CPC 3 to 4 week outlook from when we made our forecast that day. A lot of people do rely on the CPC. We can see that although this is a bit of a broader window than we're forecasting, they were calling for lots of anomalous warmth in parts of basically both coasts into Texas. Did not necessarily match the same in the central part of the US. And as we know, Dr. Decker makes his forecast 100% reliant on the CPC, and we can see for the most part, Dr. Decker did pretty well. Not one of the strongest performers, but still on the correct side of the 30-year positive CRPS score. And then for someone like Mike Garoon, who makes his forecast based off a lot of teleconnection patterns, we can look at what the teleconnections were from that period. For the most part, the NAO looked neutral, if not slightly negative. The AO, kind of the same thing. It's neutral, if not maybe even a little slightly positive. And then the PNA, slightly negative. So not a lot going on. Teleconnection, which is a testament to a strong formula by Mike Garoon, who relies heavily on those and the fact that they weren't really showing anything, and he still did well. Kudos to you, Mike. But that's kind of a pretty comprehensive overview about what this pattern looks like. Does anyone have any comments? Want to look at anything specifically? Anything they remember from making a forecast that day?
I was just going to mention, I think it was the warmest on record too for at least this time period.
check that. Yep. Warmest on record. 2008, 2011. So a lot of recent years, but this was by far, it's almost three CDDs warmer. So this was a pretty interesting period. And again, like I said, it seems that for the most part, people did a pretty good job capturing what we saw. CFS struggled. EC struggled even more than CFS, which is not something you usually see. Dr. Lupo and Dave Zarcangelo were on the correct side of the 30-year. I'm not really sure why they have negative CRPS scores. But Dr. Lupo's spread was pretty small, so maybe that's why he was penalized.
I think that's it. I think that's exactly it, Zach.
All right, well, if no one else has any more comments, we can move on. So now we're looking at the forecasts made this last Tuesday, June 9th, for the period of June 24th to June 28th. We can sort these by mean. Looks like a lot of pretty much every forecast except for CFS warmer than the 30-year. So that'll be interesting to see what people thought in terms of almost an overwhelming consensus onto what this period could potentially look like. Highest value of 54, CFS coming in at 40. So it's pretty decent spread, not some of the biggest that we've seen, but certainly some variable means across the board. Before we go into our human forecast, we can see this is what the CPC is showing. Dr. Decker didn't make a forecast, but we can just briefly show it. A lot of warmth across the board, kind of similar to what we've seen already, especially in the Southwest and along the East Coast. And then here was Maxar's report. Again, pretty strong warmth in the West, a little bit in the East. Here's the EC weekly from that day. And then here's the CFS from that day as well. All right, so now we can go into people's forecasts. I will start us off. So I made my forecast for a mean value of 52, the normal spread of 7.2 CDDs. I kept my formula the same as as pretty much the heating cooling season so far. Haven't had any reason to change it, but as we started to see overall, the 10-year normal is a pretty solid metric to lean on. So, my 60% on that is probably the reason why I've been doing well and have been directionally correct 3 out of the 3 forecasts so far. So I think in the next couple of weeks, I might try adjusting my formula in terms of just getting even better than the 10-year, but so far doing pretty well. Either way, going back to my notes from that day, there was pretty considerable warmth in both models leading up to and during our period of interest. As we saw, the CPC was showing pretty significant warmth. So without a doubt, I thought this forecast had a warm skew and it would be pretty tough. I didn't really see anything that would lead me to believe that we're going to see a shocker in terms of a cooler pattern, but the chance is always there, especially 16 to 20 days out. But again, my forecast came in about 7 CDDs warmer than the 30-year, and I definitely believe this forecast has warm skew, and I kept my spread normal. And I believe that would encapsulate any sort of variability we might see in the pattern. Anybody have any questions for me?
Yeah, I have a question, Zach. And usually when we do this for folks who aren't aware, we try to play the person that is asking the question is sort of like the industry person, and Zach is the sort of like the vendor, if you will. It looks like there's some significant cool weather moving in the next 5 days. You can pull it up if you want, but it looks like CDDs are going to actually be maybe a little bit below the 30-year nationally for the next few days. What's driving that, and what do you think the risk is that influences more significantly it kind of sticks around and keeps the extended range a little bit on the cooler side?
Well, to the first part of your question, I have not had a chance to look at these last couple of days in terms of what is causing CDDs to be cooler than normal. I can certainly get back to you on that once I take a chance to look. I'm not going to try and spitball anything. I want to give you the best information I can, but I'm not exactly sure. But in terms of how that could affect this forecast, I don't foresee that being or having any effect. Based on what I've seen and based on some of these metrics, it would appear that we are gearing up for a pretty significant warm period. So if anything, these past couple of days and next couple of days will just be a short blip of cold before we head back into a warm period.
Okay, I really like that first answer, by the way. I thought that was well done. I mean, it's so easy to get caught in the trap of just kind of like, just talking out of your you-know-what, trying to keep this G-rated today since Dr. Schaefer has a son. But, but seriously, like, it's easy to just start talking because you feel like you have to give an answer to every question. I really loved how you answered that and saying, you know what, I haven't looked at that explicitly. Let me take a look at that offline. I'll get back to you in an hour. That's a great answer. It's nice work there.
All right, let's keep things moving here. Who would like to share their forecast next?
I'll go next.
Is that Nick?
Yeah.
Yeah, all right.
So I had a pretty similar forecast. I didn't really tweak much from last week. I leaned pretty heavily on the 10-year normal, but I definitely dropped off a lot of the CFS that I had kind of baked into my forecast last week, just from looking at the data a little more closely and the conversation that we had. But it's interesting, the verification that you showed earlier was such a dramatic departure from both the 5-year and the 10-year normal. It'd be interesting to see if that maybe is a trend that we see this at the beginning of this cooling season, or if that was kind of a blip because it was such a dramatic departure. So I'm interested to get a look at the next couple of verifications.
Yeah. So again, with my industry hat on, Nick, and I know some of these questions aren't easy, right? But that's why we do this. So what do you mean by that? Like, so you want to look at, you're interested to see the next few verifications. How do you think, let's say you get those next few verifications and we do come in, I don't know, a lot warmer or whatever it is. How might your forecast formula or strategy or process change based on that new information?
Well, it would probably indicate that this year is consistently warmer than even, because the last 5 years have been warmer than the 30-year normal and warmer than most of the models predict. So I'd say I'd be less confident leaning on the 5 or 10-year normals if it becomes more apparent that we are on a more large scale kind of heating trend for this June and the end of May.
I think that's a very reasonable answer, at least in my opinion. I think you're putting multiple data points together, and that's what I like seeing. I hear you saying, you know what, I've looked at we have 5 years of performance metrics that say this happened, and And then, I'm now, again, assuming that happens, and I'm seeing a trend already in June of that same, that same effect, that, continuing warmer. And so based on this information, I may make an adjustment to my forecast methodology, and on top of that, I don't know if you said it explicitly, but, you've read a lot of research on climate change, right? And you believe that, climate change is having an influence. So you put all these pieces together and you say, this is how I'm going to adjust for that in my forecast process. Even if it's not perfectly objective, you do, I think, have a lot of reasonable data points that you're considering. And I think it's a good way to think about things.
Alrighty, who's up next? I'm trying to see who we have on the call today and who actually made forecasts. Mike, do you want to go next?
I think I forgot to make a forecast this week.
Oh, all right.
I
That's okay.
can give a quick thoughts based on what I did take a look at the teleconnections and the CPC this morning. If you want me to, I can give some quick thoughts.
Yeah, you can share your thoughts. That's fine.
So based on what I looked at, it's the warmest, just gonna say the warmest CPC forecast I think I've ever seen. Can't really recall a time where I've seen the entire map painted red like that. Other than that, the teleconnections looks like positive PNA, positive NAO, with a neutral AO, which I don't think will be having much effect on us anyway. So it would have been I don't have a number, but it would have been a warm forecast, probably in the same ballpark as everybody else. That's my 2 cents.
Sean, you want to go into yours?
Yeah, sure. So I relied mostly on the euro. Most of the teleconnections were pretty close to neutral, and the AO is trending towards a negative, it seemed like. I was gonna, initially my gut feeling was to go with a higher number. I thought it was gonna be much warmer, but I think there's gonna be more precipitation, given a little bit of a cap across from the Mississippi all the way to the East Coast. These are all assumptions, by the way. So that kind of limited it. So I gave the euro 50%, 25% to the 10-year, and then I still attributed another 25% for just a general warming trend like we're all discussing right now.
So, Sean, I do have a question for you, again, with my industry hat on. And this might be a sort of an academic point, because I don't know if it would change your number, but why did you, again, I'm playing jerky industry guy, the ECMWF, I don't think has been directionally correct so far this cooling season. I know there's only 3 forecasts, but, I don't think last year it performed that great. Why are you putting so much weight on the EC? Why do you think this time around, it's gonna more likely to be correct?
So I've kind of been weighing heavy on it for all my forecasts. I've only got a few in there. And from what I read, and this might be contradicted as soon as Dr. Trabachino comes on, that when most of the teleconnections are negative to close to neutral, the EC performs a little bit better this time of year. I can actually send some of those resources over. I can pull them up and send them to you guys. But it was some of the articles that I read. So that's why I was kind of weighing heavier on that. it could be wrong, and also those are just forecasts for the teleconnections, so the AO might not actually come out that generally or that close to neutral. Same thing with the NAO. But that's why I've been favoring it the past couple of weeks.
So, yeah, I think that's a great answer. I mean, I think that's a great answer to say, this is, I've got this stuff, I can send it over to you if you want it. And probably in a real-time situation you would. And I would just ask, if you didn't put that into your strategy section, not your formula section, but I think your strategy, definitely please do that next time, because that's the kind of information you want to put in your strategy section, so that someone else who comes along and is looking at your formula, looking at your forecast, and also a potential employer, hopefully in the future, who says, hey, I want to get some more information about Sean, they can read about that. And I think that there's a lot, that's a great point. And even you could put the link or something to some of those papers or whatever it is. So, but yeah, nice. That's a good answer.
And
Hey, Sean, could I just
go ahead,
could I
Lynn.
just clarify? Was that could you say that again? When the this time of year, the EC, what is the prediction of? It's a forecast of a teleconnection, or it's the actual S2S forecast?
So it's the actual temperature anomaly for mid-latitude at negative or strong to neutral AO and NAO values.
So negative or strong or
Strong
isn't that the whole span?
I'm sorry.
Strong or negative, positive or negative, right?
Negative to neutral.
Negative to neutral. Okay.
Yeah.
I was going to say quickly too, Sean, if you want to send, you can put them in your, you can link them in the strategies, and you can send them to me too. We have like a whole section on the website for like research materials and, things to use for people's strategies. If you want to send those to me, Dave and I can add them to the website as well. It sounds like those might be useful tips for people to use.
Okay. Yeah, I get absolutely. Let me pull them up.
I believe that's everybody, unless Dave wants to go. It's been a while since we've heard from Dave.
Yeah, sure. I can go for 2 minutes here, and then we can turn it over to Lynn. And one point I wanted to bring up, I think I have this, Zach, if you click on my read more.
Mm-hmm.
I guess I'm skipping across. My forecast process is largely the same as last week. But one feature that bothers me, and I think it could be a really good small research project, but it gives me pause on the cold side. With that said, I don't see enough yet to change my formula. But that if you look at North America's snow cover, it's extremely high on some of the charts we have. You can, if you want, you can put up on my weather prediction website, the snapshot kind of thing that you can get off the forecast contest. But just take my word for it on the different tools that I've seen. I guess Zach's pulling it up. It's very high, and associated with that, correlated to that, surface temperature anomalies in Canada are quite cold. Anomalously cold is a better way to describe that. And you can see that on one of the maps there. Yeah, there too, the surface temperature 7-day moving average. So I in the past, I looked at some research, and I found that North America snow cover / cold anomalies is correlated significantly to summer temperatures, national temperatures. Physically, fundamentally, that makes sense to me. It makes sense to me that if you have an ice box, so to speak, across Canada, that as the troughs come down, if you normally get 5 troughs or whatever, that they are going to be colder. It still depends on the pattern, but that A, that could influence the pattern. B, and I think more directly, when you get those troughs, they're going to be colder, stronger. So I'll leave it there in saying I don't know more than that, but it is certainly an interesting, I think, an interesting research topic. And I do think there's some risk there in terms of a cold risk as we get into, you know, the rest of June, July, and potentially August, depending on how this kind of shakes out.
I think that's certainly something we have to think about and keep an eye on, because when you see a table like this where it's every human and basically every other metric we have other than the CFS is forecasting for warmth, it's going to be a difficult CRPS verification if it comes in cold. And you know, what actually happened that none of us saw. So that's something to keep in mind. We'll have to look for that in the future, Dave.
Cool.
All right, unless anyone else has some last thoughts, we'll dedicate the last 30 minutes or so to Lynn.
All right, thank you. Let me just.
You want to share your screen?
Yeah. Oh, that's annoying. Okay. Hold on. Turn it on. All right, I'm just going to leave it like that because it's, sorry, my computer has issues with Zoom. Okay. Hello, everyone. I think, this isn't letting me see. 1 second. Okay, there we go. I think I know everyone on here, I believe. Is there anybody here that doesn't know me? I do. Speak up. I won't give an introduction to myself. Okay, so I'll give a small introduction to myself anyway. So today I'm going to talk about, or not exactly about subseasonal model performance, but maybe I'll introduce the question of model performance and in comparison to what I know about medium range model performance. So just a little, this isn't working. I won't change my slides. So a little bit about me. I am at Rutgers University, I am the Associate Director of the Institute for Earth, Ocean, and Atmospheric Science. I am also an instructor in the undergraduate meteorology program. And I did my PhD at Rutgers and finished in 2016 in atmospheric science. So my background is a little diverse, but generally I started out as a systems engineer in remote sensing, spent some time in finance, and then went back to do atmospheric physics and did my dissertation on improving or evaluating climate models, and have moved into evaluating weather models, or at least assessing their performance. So I am also a applied meteorologist. Been working with Dave for, I guess, almost 5 years, a little over 5 years now. And a lot of the work that I have done with Dave has been in the realm of model diagnostics. And what that means essentially for me is combining together knowledge of the model's formulation and analyses, just exploratory analyses of how models behave or how their forecasts behave in comparison to each other, in comparison to within the same model among different lead times. And then I combine that with the model performance, or what we call a skill metric. So just the mean absolute errors, mean square errors, to compare the models to each other and learn about the differences, the spatial and temporal differences in those errors. And I sort of combine all of that together to produce an application to correct medium range forecasts. in terms of sometimes making them better or whatever, I guess, application Dave had given me. We went through quite a few. Maybe sometimes the question was, you know, figure out how can you predict what the model is going to forecast tomorrow. So that would be one application of this. And then we take those sort of anything we discovered or came across and try and bring that into an operational setting so that the medium range forecast could be adjusted operationally in Dave's application. So I spent quite a bit of time doing that with medium range. I have at least a good impression of how the models ECMWF and GEFS compare to each other, how we can improve those forecasts and things of that nature. But now that we've moved into subseasonal forecasting or extended range, I've noticed these, you know, the models are technically operational. They're in commercial products now, but they're still, unlike medium range, they're still extremely experimental. So there's not, what I've noticed in these discussions is, or at least I've heard a lot of analyzing of the subseasonal models in a very similar way that we do for medium range forecasts. And the question that comes up for me is, can we, you know, do all those little biases or thoughts or rules of thumb that we have when we're doing that, do they really apply from, you know, can our perceptions of medium range forecasts you know, apply over in the subseasonal range? So I'll just give some examples to solidify that. These are just a couple of the things that that we came across in our research on medium range forecasts. So this top plot here shows the seasonal cycle of mean absolute area in ECMWF, 2-meter temperature forecast. This is over the continental United States, broken into different regions. And this was computed, the MAE was computed using forecasts from 2007 to 2013. So you can see that in days 1 to 5, the regions are all, the seasonal cycle is very similar. The numbers down on the bottom here, month 1 is obviously January through December. We can see that the error increases consistently pretty much from days 1 through 5 until longer lead times at days 11 to 15. But there's a big difference between the regions as we get out with further lead times. So there's far less variability in days 1 to 5, but in days 11 to 15, I believe that is hard to tell in the colors. But this is the southeast. That's this low one right here. So there's a significant difference between the model error on a regional basis. So that got me thinking, knowing this, you know, would this extend further in the 16 to 20? Would we expect to see a seasonal cycle that was even more dramatic with differences among the regions? And how would that factor into to your weighting of using the 16 to 20 forecast from this model, or when you're computing HEDs or CDDs? So then another example, when we compared the seasonal cycle of GEFS, we found that so something similar to this plot up here. I'm not showing it, but I've done a similar plot using GEFS. And when you compare that to ECMWF, the general conclusion we found there was that it was, as we all are aware, ECMWF is far better in winter with 2-meter temperature, but not in summer. The two models were for June, July, August. Oftentimes GEFS outperformed ECMWF, or at least the consensus should have been 50-50 if you were waiting on performance. So then one application we did of that was to, you know, say, well, if their performance is differing on a seasonal basis and there's a more optimal way to do a consensus forecast, instead of applying the 70-30 year round, we would want to bring it down to 50-50 or even 40-60 or something over the summer. So this plot on the right here just shows an average over 2007 to 2011. The mean absolute error with lead time for GFS in blue, ECMWF in red, and then the 70-30 consensus forecast, which is in green. It's hard to see there. So that's pretty much not much better, the 70-30, than just ECMWF by itself. But there is an optimal weighting, which is called the best consensus here, if you knew what it was, because based on the performance of the two models. So this, you couldn't do this ahead of time, but this is just looking back. There is some consensus forecast that's much better than the 70-30. So then that begs the question again, is this, can we extrapolate this again or no into the 16-20? And is there a best consensus in the 16-20? So it was questions like that that I started to ask myself. And I am still new to this world of subseasonal, so I can definitely say something wrong, or if there's something you're knowledgeable of, please speak up while I go on here. So my first start was when I'm looking at my whole model diagnostics process here, is really to look at the model formulation. And I think that step is often skipped, and if it's something that's very valuable to do. If you boring to read often, but when you look at the differences between the two models, some things that happen or that its behavior can be, starts to make sense a little, or you can utilize those facts knowing where the deficiencies are in each model. So subseasonal forecasts, or at least the extended range, the ones that are available from Maxar that we've been using in this forecast contest, are quite different than the numerical weather prediction models. So immediately, once you learn how a subseasonal forecast is put together, they have nothing to do with each other. You kind of have to erase your mind of everything you know about the medium range and start over sort of in the subseasonal. This is just a list of differences here on the left or the major differences between a numerical weather prediction model, so less than up to 10 days or so, and subseasonal forecasts, so 2 weeks to 2 months. Subseasonal forecasts are ensemble predictions. They are run with a coupled atmosphere ocean, like a climate model. Most weather models are not. They're run with a fixed ocean with fixed sourcing. The data assimilation is therefore much more complicated in a subseasonal forecast model, because you need to assimilate ocean data, and if there's interactive sea ice, then you have to do that as well. It requires reforecast, not just the real-time or the current analysis. The configuration can vary widely, because you have more degrees of freedom with the model configuration, and that does have a significant impact on forecast quality, but that's still something that is still being researched. It's often not taken into consideration when the forecasts are used, but it's still something that everyone should keep in mind or keep an eye on in the literature. So operations that are at an early stage, essentially still. We're in the middle of, they're being applied, but they're also, these models are really just largely being studied now too. We don't know everything about their performance, and we don't even know everything about the predictability at these lead times. So over here, so in terms of configuration, I've just listed here on the right, these are just the topics of everything that goes into the configuration that you would need to consider. And this has come from the S2S Prediction Project website. I can pass that along. There's 10 models on there, I believe, 10 operational models. And ECMWF actually has, either on the S2S prediction website or in ECMWF's public data sets, you can get data for all of these. So there's, what are all the things that can be different? The ensemble version, And these configurations actually are changing rapidly. I think there's been 4 different configurations for ECMWF in the last couple of years. So these models are actively being improved. And they do run reforecasts for each model version, so all that data is there, but they are constantly being upgraded and improved. So the initial conditions, the perturbations of the ensemble, I will provide links so there's a lot of details to go through and compare. But one of the big things is the ensemble size. I'll just highlight that one for now. You can see here, so from each model, probably Australia there has an ensemble size of 33. It has the largest, which is great. ECMWF has 11, and everything else is roughly around that size, or very small. NZEP is only 4. So, but this makes up for there's balances, obviously, like there is with any weather model in terms of resolution. You can see the resolution here is T47L17, so it's a lower resolution model as compared to ECMWF, which is very high resolution. And then another very helpful thing on the ECMWF website, for all of these models, there's a list of known issues that is extremely informative. One thing I learned about ECMWF from there is that it has trouble, snow melts too slowly in that model, and how snow is kept in the grid cell. And it's something, since we were just talking about snow cover, that just came to mind. But there are all sorts of details in there that are just worth looking over. I just want to scan through. So this is from, I don't have any plots on model performance in particular in terms of absolute error or anything like that. But they do, this is a recent paper from just this year, where they're expressing model performance in terms of, or the prediction skill in terms of days. So this is for the Northern Hemisphere extratropics, and this is looking not at the surface, it's looking at 500 hectopascal and 50. So in the troposphere and in the stratosphere for each model in the set. And this is also highlighted the seasonal variability with height. So this is over on the left here, a more detailed version of that for days in the Northern Hemisphere and Southern Hemisphere. So you can see on the left here that there's a large seasonality to the prediction skill in terms of days in these contours, and with height. And noticing that at the surface, it's not very much, it's lowest on the order of 10 days, or upwards of 12 for the summer seasons in the Northern Hemisphere, up to the top. The predictability that goes out that far into the extended range is really up in the stratosphere. So I'll just point out from this plot, you can see the annual is here on the, or the chart, sorry. Annual is here on the left, winter is in the middle, and summer is over on the right. And pretty much, so this, in terms of predictability or prediction skill in days, the furthest one out is ECMWF. So for winter, out to 28 days, and then for June, July, August, out to 14. And again, keep in mind, this is the stratosphere and the troposphere, which doesn't necessarily translate to the surface. That only happens in certain regimes. But there's an incredible amount of detail to go through that I don't have time to do here today. And I'd rather have a little bit of discussion, but or come back and look at something else in a little bit more detail. But the last thing I wanted to look at some model errors was the performance charts that are on the forecast contest. So these are from the last 6 years. I did not produce these. I know I know what everything is, but observations, I'm not sure what that, Dave, do you know what observations, where these came from?
Yeah, it's Maxar.
No, but like, I know it's their verification, but what is their verification?
Oh, this is so we're looking at cooling season. So these are population weighted CDDs.
Yeah. But what did the observation?
National population weighted CDDs. Is that what you're asking?
No, like, is it an analysis, or did they, like, they don't have, it's, nothing's called observations on their,
Oh, where do you?
this is,
On their website. I mean, it would be like the where Zach was looking earlier, where it showed you that the 47 was a record high. Those
Okay.
are their I forget what they call it. Maybe they don't call it observation.
Okay.
Something. Yeah.
okay. But looking at this, and keeping in mind that when you're looking at this across the years, is that configurations do change quite frequently. So I'm not sure if this was done using the same reforecast to go back in time. But the thing I noticed here is, on immediate glance, it looks like the CFS is always below ECMWF. They seem split on one side of the climatology and the other on the other. But in terms of how each one matches with the observations, in 2014, the ECMWF did a pretty poor job all summer. It varies. It varies each summer. There doesn't seem to be a consistent trend like there was in the medium range forecast. Because I noticed that, I don't know if anybody based this off, or you tend to look back at the previous seasons to, does anyone use these in their forecast at all?
I mean, I definitely do. I think Nick, when he was going through his forecast process, he made some sort of reference to the last 5 years. So this is in terms of historical performance metrics. We only have, at least available, we have this. And I think on that same site, we also have the correlations. And I think the correlations really are consistent with what you're saying. The correlations, yeah, there you go. Oh, you already have it. Never mind. I'll let you do
They seemed incredibly low to me.
Yeah, exactly. Not good, right?
Well, either not good or, but it doesn't look like they should be correlated that low. I'm unclear about how things are calculated. I don't want to get bogged down in that right now, but like, for example, I see in the chart forecast CDD anomaly relative to 10-year, but then the observed anomaly, is that also relative?
Yeah.
To the 10-year? I'm just wondering, because I've never, like, that, these correlations look, I expected higher correlations from, than that. But yeah, it's bad if this is all you waited on, but that's not, correlation isn't the only thing. So who did you say that? Nick?
Yeah, I took a look at these when I was
okay.
between last week's forecast and this week's forecast, just kind of to talk myself out of implementing some of the models as heavily as I had used to, because it seemed that early on in the cooling season they're pretty far off. At least the CFS is pretty low, generally speaking. Especially from 2014 through 2016, you could see it's dipping pretty low below the observations.
So right in June, we're in mid-June. Oh, okay. 2017, it was in early June, though. It doesn't seem to be as far off. It was last year, I agree. Although not terrible. But yeah, so I'm not sure how helpful this is to, to applying to your forecast. Have you used these at all before? Or is this the first time?
This is the first time.
Has anyone else? Dave, do you use these in any way? I noticed in your explanation,
Yeah.
you also had
Yeah.
Where
Yeah,
did I see it? Hold on.
I can tell you, I use them. The only way I use them, the main way I use them, I should say, is to my conclusion from this in part was based on what I saw here was to weight the EC and CFS very, very little. This informed my conclusion of that. The fact that I see 6 years where the EC and CFS scores are so low that it tells me, hey, I'm just not going to weight these models significantly higher until and unless I see real-time data start to change that, or I see some amazing research paper, that says the ECMWF that's coming out today is, significantly better than what was seen from previous summers or whatever.
Okay. So I guess, yes, I mean, the conclusion here is if these are, well, first I'd want to check these or start to monitor or use the S2S prediction database to maybe investigate the model performance a little bit more. But it does seem that it could be, I mean, what is left for you to use if you're using just, so you're left with climatologies and teleconnections essentially? Because there are other, I mean, they're exploring other areas of predictability. I don't think I've heard anybody use, maybe somebody did, soil moisture, which I would think would be important, but it seems as though the skill of the models is actually very problematic. And I guess my concern is that these are in commercial products and they're being utilized. I'm not sure by who, but so I think there's a nice project here to try to take those forecasts and try and do a decent analysis as to their performance that's explained in a way that's helpful to somebody utilizing those forecasts. And that's
Lynn,
that's all I have for now. Yeah.
That study that shows the the level of predictability drops out around 10, 12 days or 20 days in the stratosphere. How are they defining predictability? Things like precipitation is a less predictable quantity than temperature. The temperature at a moment in time is less predictable than the 5-day mean temperature. So I'm just curious what's
that is
how they're defining
defined as
prediction
the
scale
maximum lead time in days when the MSSS is positive and statistically significant at a 95% confidence level.
All right, so it sounds like it might be sort of skill score for some sort of instantaneous.
Yeah, it's the MSE, right. It's a mean squared skill score.
Yeah.
So it's it's just 1 minus the it's the MSE of the forecast over the climatology, 1 minus MSE of the forecast over MSE of the climatology.
Okay, so if someone were to do a study looking at, say, prediction of 5-day mean temperatures, they might find larger days, higher number of days than this result, I think.
Possibly, yep.
So we shouldn't give up all hope, perhaps, with our.
No, I'm not definitely no. I wouldn't give up
forecast,
all hope at all.
Yeah.
No, and I guess the other point about the reason not to give up hope is because this also changes very much depending on the pattern, the larger scale pattern that you're in, right? So in situations where the NAO is, largely positive, or whatever, certain phases of the MJO, but I think there are many more possible, sort of windows of opportunity to find where you are able to utilize.
That's very much in line. There was a talk at AMS back in January I went to where the speaker's proposition was that 90% of the time, this time range, 3 weeks, is unpredictable, but 10% of the time it is. And so the challenge is to know when you're in that 10% of the time when you can actually make a skillful prediction.
Mm. Or you're if that's for 2-meter temperature and precip, but then there's also predicting, predicting events or things like that. Yeah. So I think there's still a lot of unknown, I'd say.
Jay, Dr. Schaefer had a point. I don't know if but I'm looking on the chat. An interesting question. Maybe this is to you also, Dr. Decker. Did they talk about, he said you can't know if you're in that top 10% of the time. Is there a way to detect whether, based on certain initial conditions or certain patterns or certain types of situation, whatever, that you are in that 10% window?
So I'll have to find the talk that I went to because I can't remember. That was the takeaway I got. And I can't remember if they also went and tried to, a priori figure out, yes, I'm in this 10% of the time when I can do this. I'll have to go.
Yeah.
Talk.
Yeah.
All right, we're at 10:30 and I don't want to take up everybody's time, but does anyone else have any last thoughts or questions for Lynn or anything that we discussed today?
No, I was just going to say, I think this is really, this is definitely a much, we're seeing much more of the research side of things in today's discussion, which I think is great, and some of the potential applications, research that can be done to improve a forecast. Even just talking about the end of this conversation here about trying to identify forecasts of opportunity, they might be called. And I hope I hope we can have Lynn back maybe again to dive into some of these topics in more detail, because I think there's a lot here and potentially things that could be useful for the forecast contest.
All right, great. Well, thank you.
Yeah, thanks everybody. Thanks, Lynn, for sharing all this great information with us. And if anyone wants to talk with her further, you can reach out to myself or Dave, and we can share her contact information if Lynn's okay with that.
Yeah, that's fine.
But other than that, I hope everyone has a nice weekend, and we will be back on Tuesday with Weather Bell's Joe Bastardi from 10:30 to 11:30. So if you can make it, that'd be great. It's first time we're having him. But other than that, like I said, have a nice weekend, everybody.
Thank you, guys.
Bye.
Bye, guys.
Take care.
Thanks. Bye.